today's program which is set. I am welcome to you. So today I am going to teach the third part, that means third application of the differentiation, that is maxima and minima. Maxima and minima. So here maxima and minima, at what point the value of the function is maximum, at which point the value of the function is minimum, that we are going to see using derivative, using differentiation. Maxima and minima, let y is equal to fx. This is a curve. The any function, if it is like this, at this point x is equal to a, at this point x is equal to b. So before understanding this maximum and minimum value of the function, first we have to understand increasing function and the decreasing function. Increasing function, the value of y increases as x increases in the interval AB, then y is said to be increasing function. Increasing function. When the value of x is increases, the value of y is also increases, then the function is said to be, or y is said to be increasing function. But this increasing function we can define only in particular interval. The whole function may be increasing or may be decreasing, that is different. But we people are going to define the increasing function and the decreasing function in particular interval. So in this interval, when the value of x is increases, the value of y is also increases, then y is said to be increasing function. For example, y is equal to sin x. So in the interval 0 pi by 2. So x value is equal to 0, y is equal to 0. X value is equal to pi by 3, y is equal to half, sin 30 degree, sorry, pi by 6, sin 30 degree, pi by 6 is 30 degree, sin 30 degree is equal to 1 by 2. Suppose x is equal to pi by 3, y is equal to root 3 by 2, x is equal to pi by 2, y is equal to 1. See that the x value goes on increases, the y value is also increases. So therefore y is said to be in a increasing function in the interval 0 to pi by 2. So then the next, decreasing function. Decreasing function, the value of y decreases as x increases in the interval AB, then y is said to be decreasing function. Decreasing function. So whether it is an increasing function or decreasing function, we are going to define only in the particular interval. Suppose if we take the, for example, y is equal to 1 by x in the interval 1 to infinity, x is equal to 1, y is equal to x is equal to 1, y is equal to 1, x is equal to 2, y is equal to half, x is equal to 3, y is equal to 1 by 3, x is equal to 4, y is equal to 1 by 4, so on. So the x value is increases but the y value is decreases. This is called decreasing function. Similarly, if you take y is equal to cos x in the interval 0 to pi by 2, so that is also decreasing function. You can verify just like in a y is equal to sin x. Put x is equal to 0, cos 0 is equal to 1, x is equal to pi by 6, what you are going to write, you write x is equal to pi by 3, y is equal to sin of pi by 3, x is equal to pi by 2, y is equal to 0. So similarly, we can easily see in that where it is increases, the function is increases, where it is decreases. But you have to remember that increasing function and the decreasing functions are defined only in the particular interval. So next we can go to the at which point the value of y is maximum, the value of y is minimum. You take the interval from here to here, CD. So in this interval the maximum value of y is this. So in this interval the minimum value of y is from here to here. So the maximum value of y at x is equal to a, the minimum value of y is x is equal to b. If we draw the tangent at this point, if we draw the tangent at this point, this tangent is parallel to x axis, this tangent is parallel to x axis. So parallel to x axis, we know it very well, slope of the x axis is 0, therefore these two tangents are parallel to x axis, therefore slope of the tangent is equal to 0, and we know it very well, dy by dx is the slope of the tangent at any point. Dy by dx is the slope of the tangent at any point. Whatever it is, the value of y is maybe maximum or maybe minimum. At each point, at every point where it is maximum, where it is minimum, if you draw the tangent, that tangent is parallel to x axis, therefore dy by dx is equal to 0. Let us take this point, x is equal to a, and from the figure itself you come to know that this value of y is maximum compared to the neighbor points. You take any points in this interval, so this value is maximum. If we take this point in this, if you find the value of dy by dx, this is plus. At this point, if left side dy by dx is positive, but if you go to the right side neighborhood points, dy by dx is negative. Left side, left dy by dx is positive. At the right, dy by dx is negative. Therefore, second derivative is positive. See, from left to right, at the maximum value, d squared y by dx squared is positive. When the second derivative is maximum positive, then it is greater than 0 or positive we are going to use. So when the second derivative is positive or it is greater than 0, at that point at that point the value of y is maximum. So here you take, so the minimum value of y, take this point at this time, anywhere you take dy by dx at this point, dy by dx, actually it is 0 at the point x is equal to b, but left side if we take, dy by dx is negative, but if we take the right side of this, dy by dx is positive. So therefore at this point d squared y by dx squared is positive. Sorry, this is negative less than 0. This is positive or greater than 0. These 2 points, if we remember, we can easily find the maximum value of y function, minimum value of the function. See, this is the condition, dy by dx is equal to 0, and find the second derivative d squared y by dx squared. If it is positive or greater than 0, if it is positive or greater than 0, at that point the function is minimum. If the second derivative is negative or less than 0, at that point the function is maximum. See, actually it is negative, generally negative means less, but we are going to write in the opposite way. When the second derivative is negative, the value of the function is maximum at that point. The second derivative is positive or greater than 0, we are going to write the value of the function is minimum at that point. These are the working rules to find the maximum and minimum value of the function. Maximum and minimum value of the function. To find the maximum, to find the maximum and minimum values of y, follow the working rule, follow the working rule as shown below, as shown below. The first step, find dy by dx, put dy by dx is equal to 0 at the maximum point or the minimum point, the slope of the tangent is 0. Find the values of x, find the values of x, say x is equal to a or b or c, etc. That is the first step. Second step, find the second derivative of y with respect to x. Find the value of second derivative at x is equal to a or b or c separately. The third one, if d squared y by dx squared is negative or less than 0 at x is equal to a, at x is equal to a, at x is equal to a. The function is maximum at x is equal to a. Find the f of a which is maximum value of f(x). So, in that, and if d squared y by dx squared is positive or greater than 0 at x is equal to b, the function is minimum at x is equal to b. Find f of b which is minimum value of So, these 3 steps you have to follow to find the maximum and minimum value of the function. See, first you have to find dy by dx, put dy by dx is equal to 0, equate it to 0, find the values of x. The second step, find the second derivative, substitute the values of x in the second derivative. If we get negative or less than 0, at that point the function is maximum. Find the value of y at that point, that is the maximum value of y. Third step, if the second derivative is positive or greater than 0 at the particular value, then the function is said to be minimum at that point. You have to remember when it is maximum, when it is minimum. See, the second derivative value is negative, then we are going to say that the function is maximum. But second derivative is positive, at that point we are going to say that the function is minimum. Whenever negative you are going to get maximum, positive you will get it is minimum. You find dy by dx, equate it to 0, find the values of x. Find the second derivative, substitute the values of x in the second derivative. If we get negative or less than 0, at that point the function is said to be maximum. But if the second derivative is positive or greater than 0, then the function is said to be minimum. So, we have to remember these 3 steps to solve the problem. Find the maximum and minimum values of the given function. Now, we will do the problems on this. Find the maximum and minimum values of the function. Find the maximum and minimum values of the function x cube minus x squared minus x. Solution: let y is equal to x cube minus x squared minus x squared minus x. So, in the first step we have to find dy by dx, differentiate with respect to x, dy by dx 3x squared minus 2x minus 1. In the first step itself find dy by dx for condition for maxima and minima. Put dy by dx is equal to 0. This is the condition to find the maxima and minima of the function, that is 3x squared minus 2x minus 1 is equal to 0. That factorization, 3x squared minus 3x squared plus 3x plus x minus 1 is equal to 0. That is 3x is common in the first two terms, x minus 1 plus 1 is common, x minus 1. This is the factorization, that is 3x plus 1 into x minus 1, that is 3x plus 1 is equal to 0 or x minus 1 is equal to 0. That is 3x is equal to minus 1, x is equal to minus 1 by 3. Here x is equal to 1. See, first step is over. Dy by dx equated to 0. Solve the equation, we will get the values of x and y. Now, for the second, we have dy by dx is equal to 3x squared minus 2x minus 1. Differentiate with respect to x, d squared y by dx squared 6x minus 2. Put x is equal to minus 1 by 3 d squared y by dx squared 6 into minus 1 by 3 minus 2 minus 4. It is less than 0 or negative. The value is value of the second derivative is negative. Therefore, the function is maximum. The function is maximum at x is equal to minus 1 by 3. Put x is equal to 1 d squared y by dx squared 6x minus 2, 6 minus 2, this is 4 greater than 0 or positive. Therefore, the function is minimum at x is equal to 1. See, the second working rule is over. The first working rule is find dy by dx. Next, equate it to 0, solve the equation, you will get the values of x. The second, find the second derivative, substitute the values of x in the second derivative. If we get negative value, the function is said to be maximum at that point. If we get the positive value, at that point the function is minimum. The last one is we have to find the maximum values of the function, maximum value of the function. To find the maximum value of the function at x is equal to minus 1 by 3, put x is equal to minus 1 by 3 in y is equal to x cube minus x squared minus x. That is y is equal to minus 1 by 3 whole cube minus 1 by 3 whole squared minus 1 by 27 minus 1 by 9 plus 1 by 3. Is it? So, this is equal to 27 is the LCM, minus 1 minus 3 plus 9. 9 3s are 27 minus 3, 3 9s are 27, so 9. So, this is 5 by 27. This is the maximum value of the function at x is equal to minus 1 by 3, 5 by 27. The minimum value of the function at x is equal to 1, put x is equal to 1 in y is equal to x cube minus x squared minus 6, 1 minus 1 minus 1. So, this is equal to minus 1. Say x is 1 cube 1, 1 squared 1, plus 1 minus 1 get cancelled, minus 1 is there. So, maximum value of the function at x is equal to minus 1 by 3 is 5 by 21. Minimum value of the function at x is equal to 1 is minus 1. So, like this we have to find the using derivative at which point the function is maximum, at which point the function is minimum. We will see the next problem. Find the maximum and minimum values of the function. Find the maximum and minimum values of the function x cube minus 3x squared minus 36x plus 10. Second one, solution. Let y is equal to 2x cube minus 3x squared minus 3x squared minus 36x plus 10. So, working rule is, first step we have to find the dy by dx and equate it to 0, find the values of x, differentiate with respect to x, dy by dx 6x square minus 6x minus 36 plus 0. So, for the condition dy by dx 0, that is 6x squared minus 6x minus 36 is equal to 0, that is x squared minus 6 minus 6, that is x minus 3 x plus 2, factorization 3 2s are 6 minus 3 plus 2, that is equal to minus 1, x minus 3 into x plus 2 is equal to 0, that is x is equal to the 3 or x is equal to minus 2. So, first working rule is over, differentiate with respect to x, equate it to 0, solve for x. The second, dy by dx, we have dy by dx is equal to 6x squared minus 6x minus 36. Differentiate with respect to x, that is d squared s d squared y by dx squared 12x minus 6 minus 0. 6x squared is equal to 12x. Derivative of 6x is minus, is there minus, derivative of 6x is 6. So, second derivative, in this derivative we have to substitute the value x is equal to 3 and x is equal to minus 2. If we get negative value, at that point the function is maximum. If we get a positive value, at that point the function is said to be minimum. We have d squared y by dx squared is equal to 12x minus 6. Put x is equal to 3, d squared y by dx squared, 12 into 3 minus 6, 36 minus 6 is equal to 30. So, this is greater than 0 or positive. So, therefore, at x is equal to 3, the function is minimum. Put x is equal to minus 2, d squared y by dx squared, 12 into minus 2 minus 6, minus 24 minus 6 minus 30 less than 0 or negative. Therefore, at x is equal to minus 2, the function is maximum. See, the value is positive, but we are going to say the function is minimum. The value is negative, but we are going to write at this point the function is maximum. So, now second working rule is over. So, we have to go to the next, third. Okay. We have to find the value of y. See, at this point x is equal to 3, the function is minimum. Therefore, the minimum value of y, the minimum value of y at x is equal to 3 is y is equal to 2x cube minus 3x squared minus 36x plus 10. So, this is 2 into minus 2 cube minus 3 into minus 2 we have to substitute 3, 2 into 3 cube minus 3 into 3 squared minus 36 into 3 plus 10. So, this is 2 into 27 minus 3 into 9 . Find the maximum and minimum values of the function y is equal to x plus 1 over x. We know it very well. Y, when the function is given y is equal to x plus 1 over x, we have to follow the rules. The first rule is we have to find the dy by dx. Equated to 0, find the values of x. Y is equal to x plus 1 over x, differentiate with respect to x, dy by dx 1 minus 1 over x squared. So, derivative of 1 over x, that is equal to x to the power of minus 1. 1 over x is x to the power of minus 1. If we differentiate that, minus 1 x to the power of minus 1, that is x to the power of minus 2. X to the power of minus 2 can be written as 1 over x squared. Put dy by dx is equal to 0, that is 1 minus 1 over x squared is equal to 0, that is 1 over x squared is equal to 1, that is x squared is equal to 1, x is equal to plus or minus 1. You know that two roots are there, x squared is equal to 1. Therefore, do not take x is equal to 1, you have to take x is equal to plus or minus 1, then only x is having the two values. The first condition, find dy by dx equated to 0, find the values of x, first rule is over. For the second rule, find the second derivative of y with respect to x, dy by dx is equal to 1 minus x to the power of minus. Again differentiate with respect to x, d squared y by dx squared, derivative of constant is 0, minus derivative of x to the power of minus 2 x to the power of minus 2 minus 1. This is equal to 2x to the power of minus 3. So, in this put the value of x is equal to 1 and x is equal to minus 1. Put x is equal to 1 first, d squared y by dx squared. So, x is equal to 1, therefore, 2 into 1 to the power of minus 3. So, this is equal to 2. So, it is greater than 0, or you can say that this is positive. When the second derivative is positive, then the function is minimum at x is equal to 1. Now, put x is equal to minus 1 in d squared y by dx squared. D squared y by dx squared is equal to 2x to the power of minus 3. Put x is equal to minus 1, 2 into minus 1 whole to the power of minus 3. So, this is equal to minus 2. Minus 1 into minus 1 into minus 1 in the denominator. So, we are going to get minus. So, in the denominator. So, totally that value is equal to minus 2, that is less than 0, otherwise you are going to call it as it is negative. Therefore, the function is maximum at x is equal to minus 1. Now, the maximum value of the function y is equal to x plus 1 over x plus 1 over x at x is equal to 1. So, this is 1 plus 1 over n, this is equal to 1 plus 1, that is equal to 2. Now, the minimum value of the function y is equal to x plus 1 over x at x is equal to minus 1. So, 1 plus 1 over minus 1, this is equal to 1 minus 1, that is equal to 0. So, maximum value of the function at x is equal to 1 is y is equal to 2, and minimum value of the function at x is equal to minus 1 is 0. The next is find the maximum and minimum values of the function. Find the maximum and minimum values of the function y is equal to sin x plus cos x. Y is equal to sin x. Solution: y is equal to sin x plus cos x. The first rule, differentiate differentiate with respect to x dy by dx cos x minus sin x. Put dy by dx is equal to 0, that is cos x minus sin x is equal to 0, that is sin x is equal to cos x, that is sin x by cos x, that is tan x is equal to 1. That implies, we know it very well, x is equal to pi by 4. But we know it very well, tan is positive in the first quadrant and the fourth quadrant, x is not only pi by 4 and pi plus pi by 4 or 5 pi by 4. First working rule is over. The second working rule is we have to find the second derivative. Again differentiate with respect to x. Dy by dx is equal to already cos x minus sin x. Therefore, d squared y by dx squared is equal to minus cos x minus cos x minus sin x. So, this is equal to minus cos x plus sin x. See here, minus is there, minus in the place of sin x. Derivative of sin x is cos x. Derivative of sin x is cos x. Here cos x is there, derivative of cos x is minus sin x. I have taken a minus outside, cos x plus sin x. At x is equal to pi by 4, d squared y by dx squared is equal to minus cos pi by 4 plus sin pi by 4, which is in the bracket. So, this is equal to cos pi by 4 sin pi by 4, that value is equal to 1 by root 2. We know that, you have studied in your previous semester. So, this is equal to minus 2 by root 2. So, this is equal to minus root 2. So, this is less than 0 or negative. At this point x is equal to pi by 4, at x is equal to pi by 4, the function is maximum. The function is maximum. At x is equal to 5 pi by 4 d squared y by dx squared minus sin x plus cos x. So, this is minus sin 5 pi by 4 plus cos 5 pi by 4. So, this is equal to minus sin of pi plus pi by 4 plus cos of pi plus pi by 4. You have studied in your previous semester, 5 pi by 4 can be written as 5 plus pi by 4. You take the LCM, you will get back the same value, 5 pi by 4. So, this is equal to pi means 180 degree, 180 degree means 2 into 90. So, 2 into 90 means even multiple, same ratio. It lies in the third quadrant. In the third quadrant, sign is negative, minus sin pi by 4. Again, it is even multiple, same ratio. It lies in the third quadrant. In the third quadrant, cos is negative. minus cos pi by 4. So, this is equal to minus 1 by root 2 minus 1 by root 2. So, this is minus 2 by root 2. This is equal to minus of minus root 2. So, it is plus. So, this is greater than 0 or positive. So, at this point, at x is equal to 5 pi by 4, the function is minimum. Put x is equal to pi by 4 in y is equal to sin x plus cos x. So, this is equal to sin pi by 4 plus cos pi by 4. So, this is 1 by root 2 plus 1 by root 2. So, this is equal to root 2 you will get. So, this is the maximum value of y. Put x is equal to 5 pi by 4 in y is equal to sin x plus cos x. This is equal to sin 5 pi by 4 plus cos 5 pi by 4. I have shown already. In this 5 pi by 4 can be written as pi plus pi by 4. This is minus sin pi by 4 minus cos pi by 4. So, this is minus 1 by root 2 minus 1 by root 2. So, if we simplify that, you are going to get minus root 2. So, this is the minimum value of the function. So, just that completes the applications of differentiation. The first application is derivative can be used as a slope of a tangent. The second application is the derivative can be used as a rate measure. The third application is using derivative we can easily find the at which point the function is maximum and the function is minimum. That I have shown different problems. So, if you follow these 3 problems, similar problems you take and you practice it, you can easily reproduce in the examination. So, that completes the application of differentiation. In the next 17th of March, I will come and take the subject differential equations. Okay friends, thank you.